welcome back to some more geometry. Today we are talking about transformations in planes. So there's three transformations that we will speak about. We will talk about rotations, reflections, oops, misspelled that, reflections, and translations. So there's three examples on here. Hopefully you can kind of guess which is which. This first one right here, it's a reflection. It's pretty simple reflection, up and down. Everything on the top reflects down. The next one's rotations, kind of how the arms move here. They're rotating. And the next one's translation, the motion going somewhere upon a vertex or a vector. So let's kind of go a little bit more about these. So we're talking about transformation. Transformation pretty much means it's a function in which where we put input and it gives us an output, usually causing some sort of motion or movement. Now these transformations happen in three ways. They happen by a reflection or a flip over a certain value. It happens over a translation or a slide. It happens over a rotation or a turn. For reflection, you're going to reflect over what we call a line of reflection. There's somewhere going to be a line, and you're going to have to go from here to there, or vice versa, one way to the other. Okay, a translation means when you're moved from one point to another on a graph by along a vector. We'll speak more about vectors soon. And of course, rotation. Now you're rotating around something, that fixed point. We call that the center of rotation. So that's how that will go. Let's start with reflections. With the reflection, you're going to be given lines. So for example, here we just have a random horizontal line and a random vertical line. You're going to be reflecting over those values. So for example, here we got an A, capital A, point B, and point C. And we're going to reflect over this line right here. So that means all the values over here will be on the other side, and all the values on the right will go over to the left. So for example, point C, if it's 1 unit to the right, it'll be 1 unit to the left. B is 4 units to the left, so we'll go 4 units to the right. 1, 2, 3, 4, and A will be in the same spot. 1, 2, 3, 4, 4 units as well to the right. We connect those, and you can see it's a perfect reflection of its own self. Now, we think all right, what are we going to call these points? So we have a point A as well, point B, and a point C. But because this is a transformed version of that, we're going to call these primes, A prime, B prime, and C prime. That's what happens here as well. All right, so let's look at our example that we're going to be using here for reflections. So as far as reflections are going to go, this is what you're going to see in your homework. We're going to look at x-axis reflections and y-axis reflections. With an x-axis reflection, you're saying that everything that's on above the x-axis will be reflected downwards. Okay, so the change that's happening from going from top to bottom and bottom to top is a y value change. So that's why our equation, quote unquote, our formula says that whatever your x, y values are, you're going to change the value of your y. So for example, this point right here has a coordinate 1, 1. So my original point is 1, 1. And since I'm doing this reflection, I now will have a 1, negative 1. So now its reflective partner is right there. Okay, if I'm going side to sides, I'm doing a y-axis reflection. Going everything over here, going to the other side. So similarly, like the last one, here you're going up and down, so it's a y-axis. Here you're going side to side, so it's an x-axis change. So for example, right here I got 1, 2, 3, 4, 5, 6. The coordinate 2, 6. This coordinate right here. If I'm going to put this on the other side, on the picture it's pretty simple. Like, oh, it's 2 units to this way, so it's 2 units right there. But if you look at this, again, we're just changing the value of 1. So now we'll be at negative 2, but we're still at 6 right there. So it reflected over the y-axis. So that's x-axis and y-axis. This is what happens to those. There's one more of these. Just call it y equals x reflection. That means when it happens diagonally here. So here in this case, this is a little bit different. We have the values swap, the positions, and not necessarily the y's are now x's and the x's and y, but now the coordinates, the numbers will change. So for example, right here, this red one, we're going to use this red one as our example here. We have the coordinates 2, 1, 5, 3, and 8, 3. These are our A, B, C. So A, B, and C right there. Those are the coordinates. We're going to do a y equals, all these points are going to go on this side now. So when that happens, we're going to get a new A prime, put parentheses around that, make it proper. An A prime, a B prime, and a C prime. So our A prime will now, we swap those, will be 1, 2. Our B prime will be 3, 5. And our C prime will be 3, 8. So these coordinates will now be 1, 2. That's our A prime. Our B prime will say 3, 1, 2, 3, 5. 5, yeah, 5. That's our B prime. And our C prime will be 3, 5, 6, 7, 8. Right there, 8C. As you look at this right here, it's the same shape. It just kind of facing a different way because it reflected over this line. Look at C. C was originally pointing this way, now it's pointing up. So that will happen right there. Alright, so that's reflections in a nutshell right there. Let's talk about translations. Translations, again, like I said, it's a movement, it's a sliding. You're just shifting it from one position to another, but you're going to shift it along a vector. Let's talk about vectors. So vectors are a set of points, a set of values right here. They give it to you with little arrows at the end. Ignore the little bar that's just there on accident. So, and these right here will tell you what direction you need to go. So this first value will affect your x value, and the second one will affect your y value. So we got 2 points right here. In geometry, we care about the final answer. We do care about the process, but we care about the final. So we call this our image. This is what we're trying to figure out. What's our image here? Our image. Where it came from or where it originated at, we call that the pre-image. Pre-image. So when you see the word pre-image, image, that's what it means. Pre-image was the original one. Image is where the final value is at here. So if we look at our problem here, they gave us -3, 6. And they gave us, we're going to move this along vector 8, 2. So those values right there, like we said, we're going to affect their respective spots. So 8 is in the x spot, so we're going to take that 8, we're going to add it to 3, you get 5. And for 2, we're going to add a 2 to it, and you get 4. So this shifted diagonally that way. So kind of look at this right here. Here we got coordinates J, K, L, and M. J, K, L, and M. The coordinates for that is 0, 0. K is at 2, -2. L is at 4, 0. And 2 is at 2. Sorry, M is at 2, 2. We're going to be shifting this along the vector 3, 4. So it's going to kind of go diagonally this way up here. So by shifting this along the vector 3, 4, we now have a J prime at 3, 4, a K prime at 2, sorry, not 2, there you go, at 5, 2, that's what I have in my head, prime. L prime is now at, L prime is at 3, 7, 4, and M prime is now at 5, 6. So when we graph that, it'll be 1, 2, 3, 1, 2, 3, 4. That's our J, our K, our L, M, our K, and our L. The image didn't change sizes. It's still the same size. It's still the same orientation. It just got shifted from one position to the other. If you want to try this, you can go ahead and try this. I'll even write down the numbers for you. So A, B, C. If you want to pause, you can kind of get your own. Hopefully you paused and looked at it, and you should have got the coordinates 9, 8, -9, 8. For this one, B is at 1, 2, 3, 4, 8. -4, 8. And that should be at 4, 5, 6, 6. -6, 3. Those are your 3 coordinates for that. So when you shifted that along this vector, we would have got A prime to be at -7, 3. We would have got B prime at -2, 3. Oh, I put 8 right there. That's not right. 7. I know what did I go wrong. There you go. That should be 7. So then that changes this right here to 2. That's right. To 2. There we go. All right, sorry about that. And then C is at -6, 3. So we should be C prime will be at -4, -2. All right, so negative 7, 1, 2, 3, 4, 5, 6, 7, 3, 1, 2, 3, negative 1, 2, 2, and negative 4, negative 2, 1, 2. Right there. Again, same shape, same orientation, just shifted downwards based off the vector. All right. Now what happens at this time? I give you two images. I got you the pre-image right here. This is the pre, and then I got you the final image over here. And I'm asking you, hey, what is the vector here? What was the shift that happened from here to here? Okay. It doesn't matter which. The best way to do it on a graph, graphically speaking, is to say, all right, I can literally just count. I'm going from this B to this A. And it doesn't matter. You can do A to A, B to B, or C to C. You're going to get the same answer regardless because they all shifted in the same manner. So I did B. So for B, I went over 1, 2, 3, 4, 5, 6, 7, 8 units over to the right. So it's a positive 8. And that shifted down 1, 2, 3 units. That's a negative 3. Okay, nice. So graphically speaking, that's how you do that. But what happens if you don't have a graph? What if they just give you the coordinates? Well, let's look at our coordinates here. The best way to do it is you always take your prime. So let's say we're going to use B. Actually, use C. Let's kind of change it up. We're going to do C prime minus C. So where we finished, where we left off, minus where we came from. So let's take the coordinates of C. The coordinates of C prime. C prime is at 1, 2, 3, 4, positive 4, 1, 2, 3, 4, 5, 6. So 4, negative 6 are those coordinates. And for C, it's at 1, 2, 3, 4, 4, negative 3. So it's at negative 4, negative 3. All right. And the best way to do this, you take your new value. So we're going to take our 4 minus our original value, negative 4. And then for the other vector, you take the negative 6 minus our where we came from. So these are our C prime values and these are our C values. So when we do this, we got 4 minus the negative 4, because it's a positive, gives us 8. And we got negative 6 minus a negative 3, gives us a negative 3. So that's how we get those same ones. So if you have the image, just count over and down, over, up, however you go. But if you don't have those, you just got coordinates, you're going to have to do a little bit of math here. So remember, it's always the C prime coordinates minus the original coordinates, the pre-image coordinates. All right, that's translations in a nutshell. Let's talk about rotations. Rotations happen when you turn around something. All right, let me adjust this real quick. So there's two types of rotations when we look at rotations. There is rotations where the center is within an image. So for example, this triangle, this is the center. So that means when it rotates amongst itself. So when it says rotate 90 degrees, it's going 90 degrees counterclockwise. So what was pointing up is now pointing straight to the left. Right there. Yep. Just a little bit. Right there. Nope, too much. Right there. Perfect. Maybe. There. Okay. That's a 90-degree rotation within an image. But the majority of things that you would deal with is the rotation will happen when the center is outside the image. In this case, the center is at the origin. At origin. All right. So when that happens, same thing we're working on. So let's talk about these points right here. That point, this point right here. So this point right here was originally 1, 2, 3 points to the left. Well, a 90-degree rotation, to the right. Well, a 90-degree counterclockwise rotation will make it go up. So we're going to go 1, 2, 3 units up. This one was 6, so 1, 2, 3 more right there. And then, of course, this was over 2.5 or 1.5 and then up. So up 1.5 and over 1, 2, 3. This is now the rotated image of our original one. What happened? It went 90 degrees this way. Kind of like the moon is rotating around the earth. We never see the other side of the moon. We always see the same side because it doesn't turn. So we will always see this slanted side right here, this right here, and this right here. Once you rotate, it's the exact same thing. So that's how the rotation looks like. If we go to 180, it'll be down here. It'll be somewhere down here. So rotate another, and it keeps going all the way around. So go ahead and make sure you write these 3 down right here, because you're going to be referring back to them as you do your homework. But we're going to show you how to do a 90-degree rotation, 180, and a 270. So this is going to be our reference point. It's 6, 3. This is the coordinate of that point. So that's going to be the point that we're going to use for all three of them when we talk about the kind of rotations that we're going to do right here, 6, 3. All right, so I have the original rotation, the original point 6, 3. We're going to do a 90-degree rotation. So to do a 90-degree rotation, you're going to flip the value of the coordinates. So what used to be 6, 3 would now be 3, 6. But you're going to negate this. So make sure you do a negation of that. So right now it is positive, so then it becomes negative. But if the original coordinate was negative, it would have become positive. So make sure you understand this. We're negating, not just making it negative. It's not negative, always negative. It could be positive sometimes. All right, so let's graph that. We got negative 3, 1, 2, 3, positive 6, 1, 2, 3, 4, 5, 6. So that's where the point's at. If we did this right, that means it should look roughly like a 90-degree angle. Let's hope so. So we're going to take that, connect it to that point. That looks like a 90 degree. I hope so. Sure does. All right, good job, y'all. All right, our next one right here, as we look at it, we're going to do 180 degrees. So it should make a straight line if it's going 180 degrees. So for this kind of rotation, we will keep the values in the same position, 6, 3, but we will negate both of them. So in this case, it would be negative 6, negative 3. Let's grab those coordinates. So we got 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. Negative 6, negative 3. 1, 2, 3. Right there. That is where our coordinate's at. So let's kind of connect it back to our origin. Look at that. Looks like a straight line to me. Good job, y'all. All right. Our last one, when we look at this, 270. This similar to the 90 degree, you will flip the values of your two numbers. So we got 3, 6, but this time we're going to negate the second one on the new one. So now it's a negative 6 instead of a positive 6. So when we graph this, oh, hold on, I need to change those colors. There we go. So now when we graph this, we'll go negative 3, positive 3, 1, 2, 3, negative 6, 1, 2, 3, 4, 5, 6, right there. That's our point. So let's see if it graph looks similarly. So from here, we're going to connect it. Look at that. I like it. So when we look at this, we say, all right, the distance from here to here, that's what a 90 degree looks like. From here all the way to the purple one, that's 180 degrees. And then from our original image, our pre-image, all the way to our final image over here, that's 270 degrees. So you'll be using these right here a lot. Make sure you write them down because you're going to be referring back to them probably multiple times. All right. Our last thing to speak about here is, here's your example. So this time they gave you the original points J, which is at 3, negative 7, K, which is at 1, negative 1, and L. Okay, so we're looking at a triangle, 5, negative 3. And we are doing a 270 degree rotation. So like, all right. So again, I don't remember what a 270 degree rotation does, but let me go back. Oh, it flips it and puts negation on the second one. So we will turn ours to y negative x, like that. And I write that down because, again, I don't always remember this myself. So always have your notes marked so you know where they're at. All right, so now we're gonna do that and have a new image. So we're gonna have J prime. That's gonna be at negative 7, negative 3. K prime, which will be at negative 1, negative 1. And L prime, which will be at negative 3, 5. So negative 5. So let's think about this. We're doing 270 from this one. So here is 90. Here's 180. Here's 70. So all our points should be in this little quadrant. Here's the thing. They're all negatives. They are. This quadrant is all negatives. So let's look at that. Back this out. There you go. So let's go ahead and graph these points. We got negative 7, 1, 2, 3, 4, 5, 6, 7, negative 3, 1, 2, 3. There's 1, negative 1, 1. And then negative 3, 1, 2, 3, negative 5, 1, 2, 3, 4, 5. Right there. So as you look at this, at first as I was drawing it, like, oh, this is right, did I do it right? But I did. Because you look at the image, at all times it was pointing this way. So as it continues that pattern, it's always pointing in that direction. So when it came over here, it's still pointing in the right direction as far as how the rotation goes. So that's transformation. So hopefully that helps. I will see you guys on another day. Bye.